Hello, welcome. Let's try to solve some lowest common ancestor problems. So for Leetcode 236, lowest common ancestor of binary tree. So the binary tree definition is for a parent node, there will always be two children at most. So this is going to be a binary tree. And we are going to check the lowest common ancestor. So for example, p equal to 5 and q equal to 1. This is 5 and this is 1. And the lowest common ancestor of node 1, 5 and 1, it is node 3. Yeah. Because this is not a binary search tree, so we cannot solve it by using the log n time. So we can solve this problem by using on. By using on time, definitely. So for us, we need to check from the root node to its children. So for this node, we are starting from this node 3. Yeah. So for this node 3, we are going to check because we are going to check this node 5 and 1 as its children. Yeah. So for this node 3, we are going to check if for the left side, if I have a children that is inside P and Q, because P and Q is 5 and 1. Let me just use another color, maybe it's more clear. Yeah. So for P and Q, it is 5 and 1. So for the left side, I want to check. So from my left side in the left children, if there is a value which is inside 5 and 1. Yes, it is. And what about the right side? So currently my root node is 3. So from my right children, do I have a value that is inside 5 and 1? Yes, I have. I have a 1. So if I can find such value from the left side and from the right side immediately, so I'm going to return the root node, which is 3. Yeah, but what if I didn't find? So for example, let's just use another example. Maybe we want to find maybe p equal to 7 and q equal to 4. So this is 7 and q equal to 4. And we're going to find the lowest common ancestor. As we can see, that's going to be 2. But how can we find that? So for node 3, at its left side, we can always find p or q. Yeah, it means the lowest common ancestor must in the left side, but for the right side we didn't find anything. It means this node 3 is not the lowest common ancestor. It must be at the left side. So I go to the left side. So this is my left side. Now I'm gonna check this 5. So for the left side, it is only a node 6. It's not inside P and Q. It's not 7 or 4. So it means from the left side there's nothing. But for the right side, I can always find a node 7 or 4. It is from my right children. So I go to the right side. So now the problem becomes 2, 7, and 4. So for this node 2, I want to check the left side. From the left side, there will always be a value which is 7. It is inside the set 7 and 4. It means for the left side it is okay. Now I'm going to check the right side. So for the right side, I have a value of 4. 4 is also inside 7 and 4. It means the right side is also okay. So if the left side is okay and the right side is okay as well, so normally I can return my root node, which is this 2, directly. Yeah. Now let's just use this idea to solve the problem. Yeah. So I'm going to prepare a DFS. Yeah. So this DFS is going to be a pre-order traversal. So I'm going to prepare a node. So I want to check if node.value. Yeah, I can check the node directly. Yeah, because finally I just need to return a node instead of a node.value. Yeah, let's just check the return. And we're going to find the lowest common ancestor of 2 given nodes in the tree. And the return going to be a tree node, I think. Yeah, if the final return going to be a tree node, we don't need to check the value. So if not inside P and Q, yeah, it means the node gonna either be a P or either be a Q. So I can return this node directly. Yeah, so if not node, this means if the node is none, because currently if I check from the left side or the right side, maybe I just need to check its leaf node. So what about the children of the leaf node? It must be a noun. So I can return a noun directly. Now I'm going to prepare the left side and the right side. It's going to be the DFS with not dot left and the DFS dot not dot right. I want to calculate this value directly, and I want to use the left and right variable because later on I'm going to use this left and right. Otherwise, I have to write this DFS, and that DFS is the coding going to be quite ugly. So I want to write it concise. So now I can check the left and right. If left and right both exist, it means I can return a node. It means I've already found it. So I can just return the node directly. So if left, so I'm gonna, it means the right not exist, the right side. So I can return the left. So if right, it means the left not exist. So I can return the right directly. And finally, I just need to call the DFS with the root node any root node, because I don't need to consider this PNQ. It is just a global variable after the class. Now let me just run it to check. As you can see, it works. Now let me submit it. As you can see, it works, and it's pretty fast because the time complexity is just O(n). N is dependent on the number of nodes. It is 10 to the power 5. That is why it is so fast. Thank you for watching. See you next time.